Today we're doing section 2.4, day 2. Again, we're talking about dividing polynomials, but today we'll now kind of discuss synthetic division. So you did learn synthetic division last year in Algebra 2. Again, we're just going to kind of breeze through a quick refresher. So remember, you always set this equal to 0 to obtain the 0. So the value we're doing synthetic with is -2, because that would be the 0 of that equation. Then you write the coefficients and the coefficients only. So I have 5. Notice we're missing an x squared term, so we write 0, 6, and 8. You always draw an arrow, and that signifies that you're dropping the first term. And now we go through a series of multiply, add, and so forth. So when I multiply these two, I get -10. We add them, I get -10. Multiply, we get a +20. Add, we get 26. We multiply, we get -52. Add, you get -44. So because I started to the third power and I divided by x to the first power, I'm going down a degree, so my answer is 5x squared minus 10x plus 26, and this 44 represents your remainder. So you have two ways of writing it. You could say plus a -44 over x plus 2, or if you want, you could just say minus, and then you just keep it a 44. So either one of these ways is fine for writing your remainder. So next we're going to discuss the remainder theorem. So the remainder theorem says if I evaluate the function and I get a certain value out. So if dividing by x, so x and c are representing numbers, then c, which is your output, would represent the remainder. So just to kind of quickly go back and help you understand what the remainder theorem says, if I go back a sec, if you evaluated this function at -2 and you typed in the calculator, the answer you would get is -44. So your input, the output that you get, always represents the remainder if you had done division. So we're not going to necessarily use that theorem just yet. That's going to come in the next few lessons. So for today, I'm just going to give you the 0. But eventually, you're going to have to figure out what number gives you 0, and that's why the remainder theorem is a benefit. So because 3 is a 0, I'm going to put 3 in the box. We write out our coefficients. So I have 2, -3, -11, and 6. So I drop the 2. I multiply. We add. I multiply, we add, and we multiply. So notice we got 0, and we knew that was going to happen because they told us 3 was a 0. So I have 2x squared plus 3x minus 2. And what we would say is that x minus 3, which is where this +3 is coming from, is a factor of the polynomial. Okay, that's all for today.